All right, this is the, let's see, this is section 3.4, linear and angular speed. Let's see. Okay, well, maybe a little bit more. Okay, that's better. So this section talks about, this is all about a point moving on the edge of a circle. And we have two ways of talking about its speed. Either the distance it travels, like the distance, the typical, the speed you're used to, like maybe like a satellite orbiting the planet. It goes at a speed, normally miles per hour. So that's our linear speed. It's the speed going in this line, this curved line. We can also talk about how quickly the angle it's rotating through, how quickly that angle is changing. So that's our angular speed. So that's it for this section, talking about these two different types of speed and how they relate to each other. So you see, any point moving around the edge of a circle goes through an angular speed. Right, the angle it's moving through goes at one speed, and intrinsically related to that is how far this distance is it's going along the edge of the circle would be. So I've got some circle kind of haphazardly drawn here. It's my giant circle here. So again, any point traveling around that will have both a linear speed, which is this distance it's traveling, divided by the amount of time it's gone, and also whatever angle is traced out during that time, however many radians that goes through. So, linear speed. Now that I drew this giant thing, I'm just going to have to erase it. So linear speed the variable we're going to use for this is v. When you take a physics class or a calculus class, you'll see v used all the time to talk about velocity, but that velocity they're talking about is almost always linear. It's the linear speed you're going at. And it's easy enough to do. We take the distance we've traveled and divide it by the amount of time that takes. So divided by time. What variable do we use for distance around the edge of a circle? Well, if you look at 3.1, you already know that whenever you trace out some angle in a circle, the distance around the edge of that circle, around the circumference of the circle that you move, is called s. Yeah, that's our arc length s. Okay. So the linear speed is just that arc length, so that distance you've traveled, divided by the amount of time it takes to do that. So then your angular speed it's the angle that you've gone through in that same amount of time. Now the variable we use here is omega, or this weird looking W thing. Okay. And it's just the angle you've gone through divided by the time. Now, in keeping with our radian units, from here on out, we're just going to be using radians. So this angular speed doesn't have any unit other than radians. So no, we're done with degrees. I'll probably still mention degrees. In fact, you'll definitely have some problems that are done in degrees. You need to know that when you're dealing with this speed, you're going to have to convert that to radians. We've got some other formulas about converting between linear and angular velocity, which I may spend some time on. Probably not. No, I will. I will talk about those. But that relationship always also requires this to be in radians. So this thing's got to be in radians for this stuff to work. Okay. So what type of problems do we have here? Let's see. So here's a nice example for you. Now, some of the homework, the first few homework problems I gave you are pretty straightforward. They're going to give you some of these variables and ask you to solve for the other. I mean, they may literally just say the arc length is 5, the time is 6 seconds. What is the linear speed? What's the arc length divided by the linear, the speed? So that would have been what? 5 divided by whatever I just said, 6 seconds? 5, 6. I guess I'd have to have some kind of unit up here, like 5 inches per 6 seconds. So the first few problems should be really easy. What I want to talk about is the word problems, because that's where people struggle with this stuff. So for example, let's see. Find the angular velocity of the minute hand of a clock. Okay? Or find the angular speed of the minute hand of a clock.